Good morning, everyone. I'm Kuratul and welcome all of you to the fourth day of 1 week workshop on 5XC CNC machine, sub-sponsored high-end workshop organized by Department of Mechanical Engineering and IIT National Institute of Technology, Srinagar. Today's first session will be delivered by Dr. Noor Zaman Khan. Dr. Noor Zaman Khan is currently working as an assistant professor in the Department of Mechanical Engineering, NIT Srinagar. His major area of research includes material processing and characterization, friction stir welding, processing machining. He worked as basic scientific research fellow in a project granted by University Grants Commission. He has published around 40 research articles in international journals and conferences along with one book in CRC Press, two book chapters and two patents. With this brief intro, I request Dr. Khan to start his session. Over to you, sir.
Good morning, everybody, and I thank you for giving such a nice and wonderful introduction. And it's my privilege to be a part of this sub-sponsored workshop. In today's lecture, the topic is micromachining for industrial applications. So, in this lecture today, we are going to discuss about introduction to micromachining and why miniaturized products are required for industrial applications, and what are different types of conventional micromachining processes as well as advanced micromachining processes. And then we'll discuss what's the difference between the micromachining and micromachining. And at last, we will discuss about various micromachining of different industries or wristwatch industry or medical industry, etc. So I'm sharing my presentation. So is it visible?
Yes, sir.
Okay. So please check whether the slides are changing or not.
No, sir. No, first slide.
There is some problem. Okay, wait.
Yes, now it's changing, sir.
Okay, I need to share entire screen. So please check whether slides are changing or not.
Yes, sir, it's changing now.
Okay. So I once again welcome you all in this lecture, which is micromachining for industrial applications in an online 1 week training program on 5-axis CNC machine organized by the Department of Mechanical Engineering and IED Center. So I've already discussed about the content for today's lecture. So what are the lecture outcomes for today's lecture? So at the end of the lecture, the attendee would be able to identify the use of micromachining in industries. So you'll be able to know various types of machining processes which are being used in various industries. Second, you will understand the process of machining and micromachining, whether it may be a traditional micromachining process or it may be an advanced micromachining process. So, third outcome would be you will apply knowledge after the gain, whatever you have gained, you will gain from this lecture to select appropriate machining process for various industrial applications. Now let's talk about the introduction before going to discuss about the introduction, let's see this figure. This is Jasper Momister holding a pocket satellite. See the size of the satellite, miniaturized satellite. The space system engineers are building the next generation of mini satellites that can fit into your pocket. So soon they'll be as common as drones. Very soon. So academic research are building the next generation for exploring the potential of the next generation of mini satellites. So this is from Delft University. This is he's an academician Jasper Mister holding a pocket satellite. So this is just an example of miniaturized products which are being used in various industries. So if we talk about the increasing demand of miniaturized component, so the demand for miniaturized products has been increasing exponentially. In the past decade has seen tremendous growth in the use of these products in various industries, whether it may be a medical industry or aerospace industry, automotive, transportation, watch industry, etc. So miniaturization of the components offers various advantages. If you see various advantages, which include the higher portability because of their small size, the lesser fuel consumption of the vehicles. Why? Because due to the lightweight of the components, less volume occupancy, and low operational cost, etc. So miniaturized products can be conveniently and efficiently produced by micromachining processes, and thus these processes are gaining a lot of attention in manufacturing sectors, different types of manufacturing sectors, automotive, aerospace, railways, shipbuilding, etc. So the ability of micromachining to produce small parts of the order of from few micron to a few millimeter having complex features, and this has led to the wide application of this process in many industrial sectors such as automotive, as I said, mining, oil industries, marine, and communication technology, medical, bioengineering, or transportation, etc. If we talk about an example, miniature features, if you like filters for food processing and textile industries having a few tens of micrometer as a whole diameter and thousand in numbers. So there are various miniature features are required in different industries. If we take another example, the micron size hole on a turbine for heat transfer. So the micro machining is a derivative of conventional machining processes. Earlier we are having this turning process or milling or shaping operation or drilling, etc. So if we convert the conventional machining process, there is nothing but the micro machining. So we can derive the conventional micro machining processes from conventional machining processes, and refers to the downscaling of cutting tool size in the range of 1 to 1000 micrometer. If we downscale the tool size of a conventional machining process in the range of 1 to 1000 micrometer, then it will be termed as a micro machining. So the flexibility offered by micro machining processes in comparison to other processes has helped to manufacture various complex shapes, various curves, cavities, or microchannel, etc. So this question I have asked many times in my class of manufacturing processes, that what does it mean by manufacturing, what does it mean by machining, and what does it mean by micro machining, micro manufacturing and micro machining. These are four very important terms. First is manufacturing, machining, micro manufacturing, micro machining. Anybody? What is manufacturing in your own words?
Manufacturing is something which can convert raw material into the finished product, which will be useful for us.
Conversion of raw material into a finished product. Okay, so this is manufacturing.
Yes,
Okay,
sir.
so okay, we'll discuss about what is manufacturing in the next slide in detail. So if we talk about manufacturing, it is a process of converting a raw material of low utility into a finished product of higher value. So what we are doing with the manufacturing, or what we are doing from manufacturing, we are converting a raw material into a finished product. So what we are doing, we are increasing the value of raw material. If we take an example, this is an example. This is food. So we are converting this wood in the form of this furniture, whether it be table or chair or stool, etc. So here we are increasing the value of this wood to in the form of the chair or a table. Because if you compare the cost of this wood which is being used in order to converting the table, the cost of this wood is less compared to the cost of this table after incorporating all the expenses. So what we do in manufacturing, we just convert a raw material into a finished product of higher value. If we classify how we perform transformation of from the raw material to a finished product, there are various types of processes available, which may be a casting process, machining process, forming process, welding process, and the fifth one is rapid prototyping process. Other than these four, so what we do in casting process, we just melt the material in order to make a product. So what we do in machining process, we remove the excess material in order to obtain a product of a desired shape and size. What we do in forming process, we deform the material plastically in order to make a final product. There are various types of forming processes, which may be a rolling process, forging process, drawing process, extrusion process, etc. If we come to welding process, what we do in welding we just join similar or dissimilar materials by the application of heat and or pressure in order to make a final product. The last is rapid prototyping. There are various rapid prototyping techniques available in order to produce a final product or a component, which includes selective laser sintering or stereolithography or laminated object manufacturing, fuse deposition modeling, etc. So there are various types of manufacturing processes in order to convert a raw material into a finished product of higher value. Let's have a brief discussion about machining. A machining, it is a process in which we get the desired shape, size, and finish through removal of excess material. So there is a big confusion among the students or people, the difference between the machine tool and a machine. So if we talk about the machine, what is machine? It is nothing but a device which comprises of stationary and moving parts, which generates, transforms, and utilizes a mechanical energy. This is a generic definition for a machine. If you talk about a machine tool, so the machine tool is nothing but a machine which provides the necessary relative motion between the workpiece and the tool. It is termed as a machine tool. Any example? Anybody? Example for machine tool?
Milling cutter.
Pardon? Yes?
Milling cutter.
Milling cutter. Actually, I'm not talking about the cutting tool. I'm talking about the machine tool. Let's see the definition. This is a machine which provides necessary relative motion between the workpiece and the tool is called the machine tool. So examples are a lathe machine is a machine tool, milling machine is a machine tool, shaper machine, drilling machine, planer machine, slaughter machine, etc. So these are the examples of a machine tool. So at last, a machine tool belongs to a category of machine, but all machines cannot be called as a machine tool. So this is just a brief of machining machine and a machine tool. So before going to discuss about the micro machining, first have a brief introduction to DMU 50 third generation machine, which is available in our campus, which is a 5-axis vertical machining center. So this is the technical data for that machine, DMU 50 third generation. If you see this complex product is nothing but a hydraulic component of a motor sport bike or a car, which can be made by this machine, this 5-axis machining center. This is the how the see there are, what does it mean by 5-axis? 3 translatory axes and 2 rotary axes. X, Y, Z, 3 translatory axes, and 2 B and C are the rotary axes available in our machine. So just have where is the pointer? So this is the video for 5-axis milling machine DMG Mori 50 DMU 50 third generation, and it offers more flexibility, more reliability, more precision, and outstanding 5-axis performance. And it also possesses ergonomic design, and serious control is perfect for almost all application area. And if you talk about the bed, it has single part iron casting with good stiffness, and it also have active cooling, which is provided for avoiding thermal deformation. And in combination with the direct measuring system, the positioning accuracy is very good, which is a 6 micrometer. So the positioning accuracy of this machine is 6 micrometers, and it also possesses integrated operating interface, which is very user friendly. So this is all about this 5-axis DMG 50 CNC machine, which is also available in check करूंगा ठीक. This is also available in our workshop. So this is all about the basic or brief introduction to DMG Mori machine, which is DMU 50 third generation. Now come to micro manufacturing. If you see these figures, if you compare these parts with this pin, I'm sure that all you have seen this pin. If you compare the size of this part with this pin, then you'll be able to understand the concept of micro manufacturing. The size of and the features on these parts are of micron size. The holes on this turbine are of micron size. If you see the size of very small objects in these ICs, you see this is nothing but the portion of the aircraft wheel. See, very complex features and micron size features or components are available in this the wheel of the aircraft. And this one is nothing but the dental implant. So due to which micro machining is highly being used in medical industry. So let's have a look on the micro manufacturing. Micro manufacturing is nothing but a set of the processes or techniques which is used to fabricate micro components or microsystems, or to create micro features on micro or micro parts. So it means that micro manufacturing is not always to create a micro components or microsystems only. If we are creating micro features on a micro parts, this is also termed as a micro manufacturing. So once again, it is nothing but a set of processes or techniques used to fabricate micro components or a system or to create micro features on micro or macro parts. So today, the demand for micro components or micro systems, which is nothing but the MEMS or micro electromechanical systems, or NEMS, nano electromechanical systems, or micro reactors, fuel cells, micromechanical devices, or micromedical components, is continuously increasing. And micro components are extensively used in vehicles, aircrafts, telecommunication, IT industries, home appliances, medical devices, and implants, etc. So currently, the field of miniature technologies is a fast growing market in a broad spectrum of its application. So we are seeing day by day the size of various components are reducing day by day, decreasing day by day. I've shown you one example of a satellite. Earlier we have seen satellites of very bigger size. Now this is an era of a pocket satellite. So the presently the market demand exists not only for small parts but for small and complex features also on a large component. So what's example such as cooling holes in a turbine blade? This one, cooling holes in a turbine blade, or micro fins. If you see the micro fins on a large surface for increasing the heat transfer and similar others. So, what's the objective of miniaturization? The objective of miniaturization is either to create small parts with better capabilities or to create small features on a large component to enhance its functionality. So, the mobile phone is a good example of miniaturization, and its size has gone down from being fairly large to being less than palm size. If you see example Apple Watch, आप सबने Apple Watch देखी. If you've seen Apple Watch, the size of the Apple Watch, the function of Apple Watch is nothing but the similar to the mobile phone. So can you imagine the size or components available for these functions in the Apple Watch? So this is nothing but the example of MEMS or NEMS, non electromechanical systems. If you talk about the classification of micro manufacturing technologies, there are various technologies available to produce micro parts or components, and the selection of the type of technology depends on the characteristics of the products. So today's presentation is not on the micro manufacturing, it is on the micro machining. So I'll just discuss very briefly about the micro manufacturing process classification. There are various subtractive type, additive type, mass containing, and joining. If we talk about subtractive type, the traditional micro manufacturing processes, which include a micro turning, turning at a micro level, micro milling, micro drilling, micro grinding, etc. If you talk about advanced manufacturing processes, it will nothing but the laser beam micro machining, this electron beam micro machining, or electric discharge micro machining, electrochemical micro machining, ultrasonic micro machining, abrasive jet micro machining, abrasive water jet micro machining, water jet micro machining, etc. If you come to additive micro machining manufacturing processes, this is chemical vapor deposition, physical vapor deposition, steel lithography, liga, photoforming, polymer, etc. So this all about the process of micro machining manufacturing. Now it's time for to discuss about the micro machining. First of all, let's have a look on these figures. If you see this figure, a micro channel, various micro channels are created on the substrate of micron size. If we talk about the width of this micro channel is 285 micrometer. Width of this one is 381 micrometer. So micron size channels have been made on a macro part. So it means which is nothing but the micro machine. If you see this figure, figure number 2, this is the scale. The white one, this scale is for 100 micrometer. If you compare this scale with the width of this wall, any idea? Anybody? कितनी width होगी इसकी? If you compare this scale, this is 100 micrometer. Anybody?
Sir, 1 to 5 micrometer.
I think it should be around 5 to 10 micrometer. So we can produce a wall, a micro wall, which is of around 5 to 10 micrometer thickness. So see the technology advancement of the micro machining. So if we talk about the micro machining techniques
फिर can it use existing
have their
structure,
roots
the
in
existing
1960s
so
when the
structure
need
like
for miniaturized electronic components
except serial
arose.
number.
So if we see what is actually the micro machining, if
Yes.
we take this
Okay.
micro, if we add with this machining,
Okay.
it becomes micro
Activate
machining.
license. Tuition हो
So it
पहले.
means that a very
ठीक
generic
है सर.
definition for
Proceed.
micro machining is removal of material at
When can it
micron
use?
level.
Yes.
Very small and brief and generic definition, removal of material at micron level. It means that
Look कर अथी when you हो भी.
machining of macro components, but material
Sorry
removal is
look.
at micro or nano level.
Yes.
Or we can say that machining of micro nano components and the material removal is at micro or nano
Yes.
level.
You.
But generally, what happened actually, the notion, there is a notion that micro machining deals with machining of highly miniature components with miniature features. मार्केट में क्या ये फैला हुआ है कि माइक्रो मशीनिंग इज नथिंग बट मशीनिंग ऑफ highly miniature components with miniature features, which is literally not correct.
Third.
So what is correct? Which one is correct? What is the most more correct definition is the material removal is at micro or nano level with no constraint on the size of the component.
SolidWorks.
Now this is the most appropriate definition for micro machining. क्या है definition? Material removal
Different
is
disorder.
micro nano level with no constraint on the size of the
Ah, disorder.
component.
Sorry.
So it means that you can machine component macro component, but material removal should be at micro nano level,
Okay.
or you can machine micro or nano components and the material removal is at micro or nano level. So it can be considered as a machining of micro components, creating micro features or creating surface characteristics in the micro or nano level. Example is texturing. So what is micro machining? It is nothing but precision machining in which the machining error is extremely small. So in micro machining, the machining error is extremely small. And the micro products are widely used owing to their compact size, owing to their low material requirement and low power consumption, high sensitivity, and many other advantages over macro
Wait, no.
products.
ये और एक next करना पड़ेगा.
Now see this figure. If you see this figure, what is in which micro machining is being performed in a hole of 3 mm diameter.
कुछ download options लिखे थे.
The diameter of this is 3 mm. So first, what happened? They have selected the end mill of 3 mm diameter, and they produced hole, a array of hole, and then in this hole, micro end mill was used to
Download
produce
करो.
micro scale profile on the pattern of holes. This profile, this micro scale profile. Because this hole is of around 3 mm, so we cannot produce the star like profile by using 3 mm end mill. We require a micron size end mill for producing this profile on the area of these holes. So if you see the micron size tool, if you compare the tool with your finger,
क्या पूछे?
this is the micron size tool. See this one.
हमारी है ना production level.
I think it should be around 100 micrometer. If you talk about the diameter of this drill bit or end mill, the diameter is of around 100 micrometer. So they have used this end mill in order to produce this complex shape inside the hole. Miniaturized feature. The component size is macro. This is a macro component, but we are producing micron size feature on this macro component. So this is nothing but the micro machining. So in another figure, you can observe the micron size teeth of the machine gear. You compare the size of this teeth, this tooth, with this forceps point. So you will be able to understand the size of the teeth produced on this dial is of micron size. Another example, you see the tool tip, single point cutting tool tip of diamond cutting tool. Now compare, this is the length of 5 micrometer. So first you can be able to understand the radius of this cutting tool and the cutting edge length of this cutting tool, which is of micron size. This is a diamond cutting tool after performing machining operation. This is the figure after material addition, the tip of the cutting tool. So this is all about the example for micro machining. Very important question: why miniaturization required? Why we need to go for micro size component? Why we need to go for miniaturized products or miniaturized features? So if you talk about the answer of this question, very first, minimizing energy and materials used in manufacturing. How we can minimize the energy? How can we can minimize the amount of material or wastage of material while performing manufacturing operation? I'm giving you an example.
मतलब छू इसने ड्राइंग चेंज कर दी अचानक
Suppose if you want to reduce the diameter of a rod from 100 mm diameter to 80 mm diameter, then what will happen? 20 mm material will be removed. 100 mm to 80 mm diameter. So here we need to remove 20 mm material. However, depth of course 10 mm ही देंगे, but we'll remove 20 mm material, and this will be scrap. So in this case, the scrap material is large. Another example, suppose you want to reduce dia from 10 mm to 8 mm. एक zero हटा देते हैं, 10 mm to 8 mm. So in this case, we need to remove the material up to 2 mm. So the scrap would be 2 mm. So if you compare these two examples, you can understand that the amount of material you are spending is very less. So you can get more number of components from the fixed volume. If you are having a fixed volume and you are dealing with the macro component, you will get less number of component. So but from the fixed volume, you can get more number of component if you are dealing with micron size or miniaturized products or component. So it means that we minimize the material use. Next is reduction of power budget. How can we reduce the power requirement? How can we reduce the requirement of energy? Another example, if you want to displace large component, suppose this is component of 1 meter cube dimension. Another component is 1 mm cube dimension. Okay. So if you want to displace this large component, component number 1, component number 2, if you want to displace this large component, then you require more force, and less force is required to displace smaller component. So it means that input power will be small during micro machining. And if the component is small, then obviously it will be light, so it would be portable. Lightness and portability. So if the component is small, then it would ultimately a light component, and if the component is light in weight, so it would be portable. So what is portability? If the component is small, then it will be easily transferred to another location without utilizing highly sophisticated material handling devices. आप अपने हाथ से मटेरियल उठाया और किसी जगह पर रख दिया. So also due to portability. Next is increase sensitivity and accuracy. How to increase accuracy? Suppose If you want to move a block, again, the same example. This is 1 mm. So suppose if you want to move a block of 1 mm cube to 1 mm, 1 मीटर क्यूब का ब्लॉक अगर आपको 1 mm डिस्प्लेस करना है, and another component of 1 mm cube to be moved to 1 mm, इसको भी 1 mm मूव कराना है. The size of the component is different. Component number 1 it is 1 meter cube. Component number 2 this is 1 millimeter cube. So it would be very difficult to move the bigger component smoothly to 1 mm because it has initial friction, and to overcome this friction it will give jerk movement. But if you talk about the smaller one, it will be easy to move smaller component very precisely. So now if you talk about sensitivity, how is it sensitive? How small components are sensitive? The amount of load you required is very less, so small force will give the displacement. If we are applying very small force, say for example uh, 1 newton, so it will displace the smaller components, so it means the small components are sensitive
Islam.
and accurate too. The last one is the cost performance advantage. If you talk about the cost performance advantage of smaller components, let's take a lively example. If you take a lively example, if you put a syringe in a human body, we can feel some pain.
Okay.
But at the same time, if you put the same syringe in the elephant body, then it will not get that much amount of pain. So same thing happens
Sure.
here only. Means that the sensitivity increases with the reduction in size. तो ये हो गया ये वाला. Now if we talk about the cost performance and advantages, when you are spending less amount of material, if we are using less amount of material, if you are spending less amount of material, less amount of energy, obviously it will lead to less cost. Material requirement कम है, energy requirement कम है, तो it will ultimately lead less cost. So performance depend on accuracy, sensitivity. So if you increase the accuracy, if you increase the sensitivity, then performance will improve ultimately. So due to all these factors, we require miniaturization in manufacturing industries. We require micro components to be used in manufacturing industries. Now come to application of micro machining in industries. This is the thrust area or the main topic of this presentation. What are various applications of micro machining in various industries? So there are applications are not limited to only this: medical and dental implants, electronics, printed circuit board milling and drilling. In the jewelry, jewelry is generally made up of investment casting, but we require some mold, punch, and die, which require to be produced by micro machining. If you talk about aerospace or aircraft components or different parts made up of various materials, so we require the machining of titanium, nickel alloys, super alloys, aluminum alloys, magnesium alloys, etc. And in watch industry, miniature gears and other parts are being machined in watch industry. So if we discuss in detail, the demand for micro parts is consistently increasing in medical applications. Why? Because the human body has a limited capacity to accommodate foreign devices. Generally clear, if you put any foreign device, it will revert it back. So the human body has a very limited capacity to accommodate foreign devices. Therefore, the components of various repair and pain relief devices, it should be as small as feasible. So physicians also look for devices that are less intrusive so that there is low probability of infection in the body so as to promote faster healing. So that's why we require micro components in medical industries or implants. And if you talk about this aerospace and automobile industries, these are at the forefront in the application of micro products. These industries are mm, highly involved in using the micro components or miniaturized components in various parts. These industries are keen on introducing, why we require micro components. They are very keen to introduce micro sensors. They are very keen to introduce complex fuel injection systems, small safety devices, and microfluidics for fluid control, flow control, or micro motors, very small motors, in order to actuate, or micro actuators in their existing and new products. So a lot of opportunities of using micro machining in various industries applications like medical and dental implants. ये देख लीजिए, this is example. Micro machined implant of different material used as a dental implant. In this is nothing but the crown or attachment. This is a very smaller size. So either the implant is of macro level, or features are of micro level, or implants are at micro level as well as the feature also micro level. So that's why this micro machining is already being used in medical industry, and PCB drilling, or rapid prototyping of molds and models, etc. So these are just the limited applications mentioned here, and this is an emerging area, and the application of micro machining is increasing rapidly in various industries, owing to the era of miniaturization. If you see the figure, this figure, this is the small component of a wristwatch. Please hold on a moment. Hello, मौसम जी, ठीक ठीक, मैं उनको बुलाता हूँ, ठीक. So if you see this small component of a wristwatch, so after micro machining, see the micro features available on this component of wristwatch, and then they need to put this small component in the wristwatch. If you see the small parts, these small parts, miniaturized gears, different screws of smaller size, you'll be able to understand the size of the parts and components used in your wristwatch. This may be all about of micron size, which require micro machining in order to produce these parts or components. So, what are various materials which are being machined by micro milling or micro machining processes? If you talk about ferrous materials, it includes a mild steel, EN grade steel, or hot die steel, or SS different grades, etc. If you talk about the non-ferrous material, aluminum and alloys, brass, copper, bronze, gold, silver, various titanium, super alloys, inconel, nickel-based alloys, and magnesium or zinc alloys, etc. And micro machining is also highly being used for machining non-metals, etc. This is PVC, acrylic, Teflon, nylon, wood, glass, and ceramic, etc. So this is ceramic. We can machine ceramics as well with the help of my diamond cutting process. Very small size cutting tool uh, with the cutting edge of around 20 micrometer. So these are the materials which are being used in various industries, and micro machining is also is highly being used for machining these products, these materials. Come to the classification of micro machining. If you talk about the classification of micro machining on a broader scale, one is traditional and another is advanced micro machining processes. So, what are the traditional micro machining processes? Traditional micro machining processes have gone through continuous improvements in the design of machine tools. Machine tools are nothing but the lathe or milling, etc. So, to some extent, what happened? They can also be applied for micro machining as well, but by appropriately designing the cutting tool and optimizing the machining conditions. So if we downscale the cutting tool, and if we downscale the size of the machine, we can also perform micro machining processes by using traditional techniques. So these are characterized by mechanical interaction of a sharp and well-defined tool geometry with a workpiece. So several types of cutting processes are suitable for micro machining. These examples are traditional micro cutting of drilling of micro holes. जैसे ये देख लिए, this is traditionally drilled micro hole with the help of micro drilling operation or micro milling operation. And another example is milling of micro grooves and micro 3D shapes, turning of micro pins, etc. So if we talk about this micro milling is widely used for fabrication of micron size grooves or small cavities or 3D concave and convex shapes. And micro milling with tungsten carbide tools can be used for machining various materials such as steel, aluminum, brass for making micron size or miniaturized components. If you talk about micro drilling has been widely used in various industrial applications. If you take an example, drilling of micro holes is in most metals, plastics, and their composites can be comparatively easily done. So we can easily drill a hole of micron size with the help of micro drilling in various materials, including most of the metals, plastics, and their composites. So if we take one typical example of micro drilling is laminated printed circuit boards. In PCBs में generally we go for micro drilling operation, conventional micro drilling operation. The important thing is the straightness and the uniformity of the size of the tool are important. These are various issues in micro drilling. If the tool is not straight and uniform, it is very difficult to perform micro drilling operation. So also it is very important that we need to be very careful about the correct location and orientation of the micro tool to avoid defective holes. So this is, if you see this figure, this is the hole drilled by micro drilling, and the size I think is around. If we compare this bar, which is of around 50 micrometer, it means the diameter of this hole is nearly around 100 micrometer. So 100 micron size drill bit was used to perform this micro drilling operation. So now come to advanced micro machining processes. If you talk about advanced micro machining processes, see, actually, though we are having these traditionally available micro machining processes, then why we require these advanced micro machining processes? Earlier we were having micro turning, micro milling, or micro drilling. Then why we need to go for advanced micro machining processes? Why? Because owing to the development of new materials that are difficult to machine and stringent requirement of the parts used in high-tech industries, and many advanced micro machining processes have come into existence because new materials are being developed with very high hardness and various other properties which are desirable for manufacturing industries. So various machining advanced machining processes are available which can machine these materials economically, efficiently, and with high accuracy. Economical is very important. So we can use advanced micro machining processes economically in order to machine new materials which are very difficult to machine by traditional machining processes. So consequently, advanced machining processes provide effective solution to the problems imposed by increasing demand of high strength, temperature resistant alloys and the requirement of parts with very intricate and complex shapes. So these materials are so hard to defy machining by traditional methods. So that's why these processes are advanced in the sense that why they are called as advanced micro machining processes. Advanced less why we have used advanced word because they do not imply a conventional or traditional tool for material removal. Instead, what they require, they directly utilize some form of energy. They directly require some form of energy for micro machining, whether it may be a thermal energy or whether it may be beam another energy or whether it may be a chemical energy or whether it may be mechanical energy, etc. So these processes are classified into various groups. So if you talk about various advanced machining processes, if you take an example of this laser beam micromachining, when we use this laser beam micromachining, laser beam micromachining generally uses different types of pulses, a long pulse or a short pulse or ultra short pulse. So if we use a short pulse laser, it can produce a feature as small as zero point 0.5 micrometer size. zero point 0.5 बस ठीक हो गया. So laser beam micromachining can produce a micro feature of around zero point 0.5 micrometer size. See the accuracy and precision. So it is used in producing MEMS, micro electromechanical systems. Laser beam micromachining is highly being used in micro electromechanical systems. So if we take an example about these systems, like computer hard disk drive head, or inkjet printers heads, or sensors, or IR imagers. And if we talk about the modern printers, they have a nozzle of size around 300 into 28 micrometer. मॉडर्न प्रिंटर की नोजल का साइज क्या होता है 300 माइक्रोमीटर बाय 28 micrometer. So in order to produce these types of nozzles, we require advanced micromachining processes. So laser beam micromachining has so many other applications, including marking, engraving, etc. If you see this figure, where is the pointer? This figure number 1, figure number 2, and figure number 3, figure number 4. So we see the figure, which is figure number 1. This is a laser cut stent-like pattern in miniature stainless steel tube with 1.25 mm outer diameter. If you see this tube, which is of outer diameter of around 1.25 millimeter, it means that these features are of micron size. It has been produced by laser beam micromachining process. Another application is laser drilled hole, which is dia of around 15 micrometer, and the pattern in polyurethane tube. These are micron size features hole by using laser beam micromachining process. Now come to electron beam micromachining process. Time is 11. Electron beam micromachining, it can produce hole as small as 6 micrometer. इसका resolution क्या है 6 micrometer. So we can produce 6 micron size holes by using electron beam micromachining. Sometimes what happens if the intensity of electron beam is very high, then the part may get overheated and get damaged. If we take an example of this electron beam micromachining, see this is a pattern of hole of around 90 micrometer. The dia of this hole is 90 micrometer, and the density is 4,000 holes per centimeter square. So a pattern is required. Pattern of hole is required. The workpiece is a stainless steel workpiece, and the thickness of this is 200 micrometer. So if you see the productivity of electron beam micromachining, the productivity is it can machine one hole in 10 microseconds. So it means 10 microseconds per hole. If you go for further magnification, this size of hole is around 6 micrometer. So what I said earlier, electron beam machining can produce a hole as small as 6 micrometer in a thickness of 120 micrometer, and the productivity is as 2 microsecond per hole. So that's why we require advanced micromachining processes. Come to electric discharge micromachining. Electric discharge micromachining or machine, it removes material by thermal erosive action of electrical discharge produced between the tool and the workpiece. And this machine is suitable for machining difficult to machine conducting materials. What are difficult to machine conducting materials? Very hard materials, super alloys or tungsten carbide, etc. So we can machine regardless of the hardness, we can machine any conducting material with the help of electric discharge micro machining. But nowadays, if you talk about the research and technical advancement, we can also use electric discharge micro machining to machine ceramics as well. Okay, now if you talk about electrochemical micro machining, electrochemical micro machining, this process is generally practiced in aerospace industry or automobile and other heavy industries for shaping and sizing, deburring, and finishing operations. And a variety of metals and alloys, including conducting ceramics, can be machined by electrochemical machining, micro machining process. So there is some limitation that the material should be electrically conductive, but a new process has been developed, which is termed as electrochemical spark machining. This process is developed for machining ceramics. Now this is next is ultrasonic micro machining process. So yeah, this is a very valuable process for precision machining of hard and brittle materials, whether it may be conducting or non-conducting. So the tolerance up to plus minus 5 micrometer can be achieved in this process. If you want to machine hard and brittle material, whether it may be conducting or non-conducting, you can go for ultrasonic micro machining process with a tolerance of around plus minus 7 micrometer. And the best machining rate can be obtained on materials harder than 60 HRC. अगर कोई material है जिसकी hardness is more than 60 HRC, then you can get very optimized material removal rate and productivity by using this process. But the accuracy is not as good as laser beam and electron beam. Ultrasonic machine can produce a hole as small as around 70 micrometer in diameter. 70 micrometer in diameter, and the process is very useful for producing microcavity. So there are other processes as well: abrasive jet micro machining, abrasive water jet micro machining, water jet micro machine, etc. Now there are other advanced finishing processes too. I'm just giving you example of in a single line that by using MR finishing process, you can obtain a surface roughness up to 10 nanometer. Can you imagine 10 nanometer of surface roughness you can achieve from magnetological machining process, finishing process. So this is all about the micro machining classification. Next, time to discuss about what's the difference between the macro and micro machining. First, the micro products are preferable over macro products because micro products are widely used owing to their smaller in size, owing to their compactness, low material requirement, low power consumption, high sensitivity, and many other advantages over macro products. Now, if we see the size, what is the influence of size or influence of size effect? Actually, the fundamental mechanism between the macro and micro cutting can be different due to the size, due to substantial size reduction. If we reduce the size from macro to micro, then the process mechanism is also different. It depends upon the reduction in size. Now we'll see what is the effect of reducing size. The size effect has influence on various aspects. So number one is cutting force. What will happen if we reduce the size on the cutting force? So if we reduce the size, the chip thickness would be small. If the chip thickness would be small, the cutting force will also small, and less material will be removed. So if we reduce the size, then the chip thickness will reduce. If chip thickness will reduce, then ultimately the cutting force will also reduce. Chip thickness will be very less if we reduce the size in micro machining, and there will be a large variation between conventional machining and micro machining. Conventional machining में chip thickness बहुत ज़्यादा होती है, and micro machining chip thickness is very less. Chip formation. So if we do machining at a very small scale, then there is a chance that you may not get chip at all. कभी कभी chip बनती नहीं. What happens? Suppose this is the material. So no, very small depth of it actually. This is cutting tool. So what happens sometimes if the uncut chip thickness is very small, then there is a chance of rubbing the tool against the workpiece instead of chip formation. So the chip formation is not the guarantee in micro machining. It will depend upon the ratio of uncut chip thickness and the radius of the cutting edge. This is the uncut chip thickness. Uncut, see, this is H is suppose uncut chip thickness and R is the radius of the cutting tool. So it will depend upon the ratio of H by R. So this is another problem with the micro machining. We need to be very careful about this ratio because sometimes chip won't form at all. A small uncut chip thickness. So if the uncut chip thickness is very small, it will lead to low cutting temperature. जब uncut chip thickness small होगा तो temperature low temperature will generate. So with the large depth of cut, temperature will high, and rise in temperature. What we do, right? Rise in temperature is advantageous for reducing the applied load due to softening of the workpiece. Macro machine में advantage होता है. If we talk about micro machining, the uncut chip thickness is large. So if uncut chip thickness is large, the degree of deformation is also large. If the degree of deformation is large, it will generate higher temperature. Higher temperature will soften the workpiece and it will reduce the cutting forces. But in micro machining, the uncut chip thickness is small, temperature will also small. So what happen? It will be advantageous for softening the workpiece. So what will happen? Due to low temperature, it will lead to high shear yield stress of the workpiece. अगर टेम्परेचर कम होगा तो shear yield stress will increase. It means that more amount of force will be required to cut the material. So in this, we require the force would be high. And here we are saying the force will be reducing. So this is a very complexity in micro machining because very less mechanics available on the micro machining, a large literature available for macro machining. So this is also very challenge in micro machining process. So this is the difference between if we reduce the size of the component. So this is the influence of size effect on various factors. Now, there are various traditional micro machining processes, but I have selected or chosen only micro milling because we are having the same facility available in our campus. So let's have a look on a video what is actually micro milling. Now see this is micro milling process. So we are currently they are using a macro and mill of around 3 mm diameter, 3 mm diameter of micro mill. So after that, so actually what is milling? Milling is nothing but one of the primary operations followed by grinding, heat treatment, etc. And if you talk about micro milling, in which the cutting tool is as small as 100 micrometers. If you talk about micro milling, we generally use, actually myself, I have used end mill of 200 micron size diameter. I have performed micro milling operation by using 200 micrometer diameter. But generally, we can also use 100 micrometer end mill to perform micro milling operation. But the cutting tool material, the coating and geometry needs to be very accurate for performing micro milling. And there is no secondary. Why we require micro milling? because no secondary finishing operation like grinding may be possible. At some, in order to produce very intricate and complex shape where the grinding is not possible, then we need to go for micromilling operation. And the machine position accuracy should be less than 10 micron. If you need to perform micro milling operation, then the machine position accuracy should be less than 10 micrometers. So our machine having 6 micron size accuracy. And with proper tooling and process optimization, we can obtain surface roughness of the machine component less than zero point 0.2 micrometer with proper tooling and parameter optimization. So how to avoid, say, if we use a very small size end mill, and generally cutting forces are generally acts while performing machining. So how to avoid tool breakage? I have performed micro slotting operation with the help of 200 micrometer. So we have used around 3 to 4 end mills. So how to avoid tool breakage? So if you want to reduce tool breakage, you need to decrease the cutting depth, and you need to check the run out. If the tool breaks at the beginning of the machine, then decrease the plunging feed rate, and use a coating to improve the tool life. So now they are using flat end mill up to from 3 mm to around 1 mm, 1.1 mm end mill, 1.1 mm only, around 1100 micrometer. So they are performing drilling operation by using this end mill. Now see, this is now they have used 190. They are producing 190 micrometer depth channel by using 0.005 end mill, 0.005 inches. I need to convert this, which is around 120 micrometer. Now they are using 120 micrometer end mill in order to perform, in order to produce one channel on this component. So again, I'm calling it as a micro milling, but the component size is of macro size. That means that machining macro component in order to produce micron size feature, it also comes under the category of micro machining operation. So this is the final product. Now let's discuss about the micro milling of a micron size wall. So micro wall, after dividing the height into several layers of a few micrometers, the layers are machined in sequence. Sequence में ये layer machine हुई हैं. The workpiece for machining the walls measures 2 mm into 2 mm. If you talk about the measurement of this workpiece, 2 mm by 2 mm, so it means that of macro size. And the cutting depth is 5 micrometer, and the gap between the wall is 200 micrometer. And the thickness of the machine wall is 25 micrometer. If you talk about the thickness of this wall, if we talk about the thickness of this wall, this is of around 25 micrometer, and the height of this wall is around 650 micrometer. So this wall produced with the depth of cut 5 micrometer. Depth of cut कितना? See, this is depth of cut of 5 micrometer with RPM 25,000 RPM. They've used a carbide flat end mill of 200 micrometer in order to produce this micro wall. So compared to the typical machine surface, this have a smoother surface, and however the machine surface may seem excessively rough due to very high this photographic enlargement scaling. इसका स्केल किया हुआ है सेम से, इसलिए थोड़ा सा ब्लर लग रहा है. Micro column with rectangular cross section. So in order to machine a column with a rectangular cross section of around, if we compare this white bar, this the length of this bar is 50 micrometer. So it means that the size of this rectangular column is, I think, around 30 micrometer by 30 micrometer. This 30 and this 30. So this base was cut with a cutting depth of again 5 micrometer, and again next 5 micrometer step over until the desired size is achieved. So this method reduces the applied forces on the machine column, and thus it reduces the deformation of already machined section. So this is some image of this machining of micro column with rectangular cross section. So this is the strategy of machining this column. They have used a cutting to end mill, and they have performed machining on this side. So this is the final product. Micro column with circular cross section, the same similar operation, similar strategy they have used in order to perform machining operation to obtain micro column. And again, the diameter of this column is the same 30 micrometer, and the height is 650 micrometer. Now see the micro impeller and the base. See the micro impeller. If you see the features of this micro impeller, the height is 60 micrometer. The shaft dia of this micro impeller is 200 micrometer, and this width of the blade of micro impeller is 300 micrometers. But the component is macro. 3 by 3 component is macro component. So to demonstrate the potential of utilizing a 5-axis micro milling machine, I also plan to produce these micron size component in our machine, a 5-axis CNC machine. For that, I need to purchase micron size and mill, say for example 100 micrometer, 200 micrometer, etc. So at first, what happened? The shaft of the impeller was machined as a cylinder. जैसे हमने सर्कुलर कॉलम बनाया था. The impeller blades were completed using a similar method to machining curved micro valves with the help of 5-axis CNC machine. And the diameter of the tool that they have used is 200 micrometer. So this is the image of micro impeller and the base block in the assembly. See this same image. First they have made the base separately, and then they have made the impeller. After assembly, it will look like this. This is the micron size impeller. Of outer diameter is around 800 micrometer. This is the machining of microblade. Just see this. This, if you see, the length is of around 100 micrometer. So it's the width of this blade is around 200 micrometer. So this is the machining of microblade. These are various challenges of micro milling: how to achieve super surface finish, how to enhance productivity when tool size is very small, we need to for coating and tool material, how to determine cutting parameters, how to eliminate vibrations, how to minimize chatter, and which is the suitable CNC control. This is also very important. If the accuracy of CNC control is not good, if the accuracy of the CAD/CAM software is not good, then it is very difficult to go for micro machining operation. How to enhance the tool life, how to prevent deformation of small thing or piece. I wanted to discuss this with you. ये मैं discuss कर लेता हूँ एक बार. If we talk about this micro slotting of aluminum alloys, just have a look. I performed 27 experiment with I think the diameter of 2 mil was 200 or 400 micrometer around. This is the micron size and mill. So I performed 27 experiments. Here I have considered only 9 experiments in order to show you the effect of the cutting parameters on the surface roughness. So I have taken 3 values of speed: 4000, 6000, 8000. The feed rate was constant. The depth of cut 3 values: 20 micrometer, 40 micrometer, and 60 micrometer. If you see the effect of depth of cut with 400 rpm, 20 micrometer. So this is the effect of speed: 600 rpm with the same depth of cut, and 800 rpm with the same depth of cut. So here, if we are increasing the cutting speed, then the surface roughness is decreasing. Why? Because if you increase the cutting speed, the cutting force will decrease. If the cutting force will decrease, ultimately it will reduce the surface roughness, and it will enhance the surface finish. Now the same, if you see the effect of speed with different value of depth of cut. You see the effect of speed with different value of depth of cut. In this case, the depth of cut is around 60 micrometer. Class. So at 400 RPM with 60 micrometer depth of cut, we have achieved 0.139 micrometer roughness. If we increase the RPM, the roughness is decreasing. But if we further increase the RPM to 8,000, the roughness start increasing. This is the trend. 4,000, 6,000, and 8,000. So what's the reason? If you increase the rotational speed, the cutting force will increase, then it will ultimately has to reduce the surface roughness. But in this case, if we further increasing the rotational speed to 8,000 RPM, then it is increasing the surface roughness. So the reason might be the tool wear. So you'll say that, sir, why it has not happened with this 200 micrometer? It means that if we are using depth of cut, it won't have a significant effect on the tool wear. But if we further increase the depth of cut to 60 micrometer, it will significantly affect on the tool wear. Another example, if we are considering 40 micrometer depth of cut, and if you see the effect of rotation speed on the surface roughness, so at 4,000 RPM, the roughness is around 0.190. On 6,000 RPM, the roughness 0.123, and 8,000 RPM, the roughness same. It means that from these 9 experiments, what we conclude? We conclude that at 20 micrometer depth of cut, the effect of RPM on the surface roughness is significant rather than the effect on the tool wear. If you talk about the 60 micrometer, it means that the effect of RPM on the surface roughness is significant up to 6,000 RPM, and if you further increase the RPM, the effect of RPM on the tool wear will increase. But at 40 micrometer, what happened? The effect of RPM on the surface roughness as well as on the tool wear is near about same. So this is the conclusion of this slide. So I'm having 2 videos for this. I'll take not more than 1 minute. This is just an overview of the micro machining of a wristwatch with the help of micro milling. So the size of the wristwatch is of macro size, but here the micro features are being produced with the help of micro milling by using a micron size and mills or drill bit. And at last, this is the micro machining in medical industry. So you can see the size of this lens. It is very clear. This is an intraocular lens. It is a tiny artificial lens for the eye, and it replaces the eye's natural lens that is removed during cataract surgery. देखिए कैसे मशीनिंग होती है यहाँ पे. The machining of this lens is being performed on acrylic. See the small features. So thank you very much. This is all about today's presentation. Correct 11:30.
Thank you, sir. Thank you for your wonderful lecture.
So okay, thank you very much for giving me chance to give an expert talk on this wonderful workshop training program on CNC machine. So thank you very much all participants for attending this class. Thank you very much.